So about 5 years ago, I wrote a proposal called Proof of Activity. It was a little twist on proof of stake with proof of work, where every block that's mined, one random person is chosen to be the signer of that block, and he has to spend that transaction, and he gets paid a little bit of money, but that spend will actually sign the block. So because of that, it's hard to 51% attack it. Because if you're doing it hiddenly, you wouldn't be able to sign the blocks that you mine, because unless you have a huge stake, it wouldn't randomly pick the keys that you own. So, and then some developer took that forward and tried to work on an altcoin. And Jake and his team was also working on an altcoin called Decred, which had something similar ideas, and those two projects merged. And that's when I first heard about Decred. And then recently, I got reminded about Decred again, and I looked into it, and I saw that they really took my initial idea forward, like made it a lot better. And so here, welcome Jake to talk about Decred.
Thanks, Charlie. So, that's my friend Daisuke. Okay, so I'm here to tell you guys about Decred. My name is Jake Yokenpayat, as Charlie said earlier. This is sort of an overview. It's meant for a kind of technical audience, so hopefully it won't be incredibly boring if you guys are engineers, which I presume a fair fraction of you are. So in terms of how this is laid out, I broke this apart into an introduction and a couple parts where I'm going to cover hybrid proof of work, hard fork voting, and the sort of design principles we use to build out Decred. I think it's important because Decred is basically a variant on Bitcoin. To start with a very brief summary of Bitcoin and what is interesting about it. So instead of making the sort of usual summary of Bitcoin, I tried to sort of put a spin on it and make it a little bit more interesting. So it's if you're at all familiar with anonymous bearer share corporations, which I assume most people are not, Bitcoin is a pseudonymous digital bearer share entity, and it self-issues shares based on solutions to computational puzzles. There is a notable sort of shortcoming with Bitcoin, which is that the proof of work miners have a monopoly on the right access to this ledger. That is, if you're a random Bitcoin user, you can create a transaction and then you relay it, but you have to just hope that a proof of work miner mines it into a block and puts it on the chain. These computational puzzles basically amount to a lottery across the hashing power, because if you have 20% of the hashing power, you can expect over time to roughly mine 20% of the blocks. Now, this restriction on right access to the ledger creates an odd splitting, because I think with Bitcoin, the original idea was, let's do something that no one else has done. Let's get rid of the third party. But in doing that, there's some extra complexity that comes up. In order to get rid of the third party, you needed to create a proof of work, a proof of work solution to a problem. And what that did is that basically took certain rights away from people. I mean, with a bank, you're never guaranteed that the bank is going to send your transaction. You can try to send a wire transfer wherever you want, and the bank may go, whoa, that's not going there. We're going to put a stop on that. And in a sense, that's what proof of work miners can do, but it's obviously not the same in the sense that it's distributed. One person might mine your transaction while another might not, and so on. So so as a Bitcoin holder and not a proof of work miner, it's almost as if you have Class B shares of a corporate entity, and they have the Class A shares where they can sort of twist things and control things in a way that you simply cannot without the proof of work mining hardware. So it is, I figured making an abridged summary of what I'm doing here is useful in the sense that what we do builds on Bitcoin very much. It's not like Ethereum or Zcash or Monero in the sense that it's really its own full-on altcoin. This is based on Bitcoin, and then we sort of observed what we felt was wrong with Bitcoin and tried to tweak it so that we could fix it. So it's very similar in terms of the definition, but what you'll notice is that there's more than one way for the self-issuance of these shares to occur. Beyond the computational puzzles, users can lock coins to participate in a voting system, which I'll get into more details about later. And there's also some funds that get put aside every block for development, because building out the infrastructure becomes a tragedy of the commons if you do not do this, as anyone familiar with Bitcoin is aware. So instead of just proof of work miners having the ability to write to the ledger, we added proof of stake miners, and they also have the ability to write to the ledger. But the restrictions on who is and is not a proof of stake miner are intentionally much less than people who are proof of work miners. Instead of just there being these computational puzzles that amount to a lottery across hashing power, there is an actual lottery of tickets. So it's a little bit more explicit and less abstract than Bitcoin in that sense. So you basically lock coins. Locking the coins gets you tickets. The tickets go into a rolling lottery. Some old person turns the crank and they pull it out and someone gets excited. And that happens over and over again. If you want to, you can participate in proof of stake mining. It's not obligatory. Charlie's proof of activity proposal. In that proposal, it is either mandatory or semi-mandatory that you participate in order for the proof of stake to show up in the blocks. Whereas here, if you don't want to participate in proof of stake, you don't need to. It's totally voluntary. If you care about management of the coin and so on, you can participate. If you don't, you can hide at home and just hoard your coins. And the idea here is to set up proof of stake as an override for proof of work. Proof of work, is automated, but it has these problems, right? Where effectively the shareholders of a company don't really have say over what goes on in the company. So what we're trying to do here is just fix that problem so that we go, the people who hold the coins are really the ones in charge, not necessarily the people who own this mining hardware that's located somewhere in the mountains in China. So because of this write access problem with proof of work miners, they're really the ones in control, and we're just trying to right do what we perceive as right the ship. So understanding the motivation for the changes we made is important because without some context, it's just more features and more complexity and more junk, and the question becomes, do you really need it? So the consensus system we settled on, it's part proof of work, part proof of stake. And we're trying to break up this monopoly that I've been talking about in terms of write access to the ledger. The issues that people vote on, basically what we wanted to do was sort of distance ourselves as developers and maintainers of the project from the changes that occur. And we can do that by basically requesting input from the proof of stake miners. Proof of stake miners can go, oh, I really like this, I really don't like this, and give us feedback sometimes before we do development work. Sometimes it can be changes like, oh, we want a larger block size, we want a smaller block size, we want to change the difficulty algorithm. All of these things are up for changing. It's just a question of how many people want it, and if there's a firm majority that wants it, it can happen. The tragedy of the commons that has occurred with Bitcoin is pretty serious in that, anyone who was doing core development for the past several years, at least until, say, Blockstream came around, or I did with BTC Suite, that work was basically unpaid. It was charity work. If you happen to purchase a large number of coins, up front, and then you can sort of ride the wave for a long time, you made out fine. But in general, building great products requires money. I'd expect that's especially tangible to everyone here at Coinbase. Coinbase isn't just going to build itself out of someone's charity. It'd be like, oh, hey, I would have this great exchange and a great website and support staff, and that takes money, time, and that's got to come from somewhere. So what we decided to do was take 10% of every block subsidy and push it into a fund that's run by temporarily a centralized entity and oversees development, marketing, and all the other infrastructure building that has to happen with a cryptocurrency. So I figured we'd zoom in, and there's three topics we're going to cover for the rest of the talk. We're going to talk about design principles, because I think I would be remiss to ignore the smart design choices that were made with Bitcoin and the way it was implemented. Hybrid proof of work, proof of stake has a lot of details, and I'm going to try to cover as many of those details as I can in a reasonable time period. And then hard fork voting is really the most useful application of the hybrid proof of work, proof of stake system, in that it allows users to vote on the most fundamental, low-level changes you can make to a cryptocurrency, which is basically changing or updating consensus code in a way that's relatively continuous and minimally painful, and is sort of not micromanaged by people like me. That is that, we push changes out, people have an opportunity to vote on them, and then we see what happens, as opposed to me trying to sort of, ram through changes on people. Get ahead of me. So the design of Bitcoin, I think one of the more interesting things that has happened with it is that it's a many birds, one stone approach to development, which is, as we're all aware, with code, you can just add complexity on complexity on complexity, but it has to have high enough utility to justify the complexity. And so Bitcoin, knocked out a lot of things with one system, and it is impressive and bears a quick review before we start talking about how we did it with Decred. So to summarize the changes, the major observation, the major trick here is gamification of timestamping. Timestamping is something that typically has to be done by a centralized entity, and by turning it into a computational puzzle and creating competition for solving that puzzle, and it becomes a lottery, and people want to participate. And the reason people want to participate is obviously that the winner of every computational puzzle is awarded some number of Bitcoins. And the puzzle process becomes a means of automated issuance. Without, basically overlaying these various features, Bitcoin really couldn't have happened. On top of it, the sort of output or the sort of utility that is derived from these two things, the gamification of the timestamping and the issuance via the timestamping mechanism, is it makes it very censorship resistant, because no one is really in charge. It's like if you've seen the movie The Hangover 2, and they joke about who's going to arrest the monkey. It's the same phenomenon, which is that you can try, with a bank, you could claim that the bank is complicit in something questionable going on at the bank, right? Somebody's sending coins for something on a dark market, or sending dollars for something on a dark market. Then the bank gets them involved and they're responsible. Whereas, with spreading it out with Bitcoin, really no one's responsible, which works out kind of nicely. So we decided to try to reproduce this many birds with one stone approach with Decred. Sure, it makes a mess, but there for somebody else to clean up. So in 2013, Adam McKenzie wrote a white paper for Memcoin 2 and proposed the hybrid proof of work, proof of stake system that we ended up using in Decred. And this was work done essentially concurrently with Charlie's work for proof of activity. And the difference is that on top of there being a proof of stake layer, people were voting. That is, with every proof of stake, component that went into the blockchain, there was a vote attached to it. On top of that, the votes had additional utility beyond just saying yes or no on a given issue. These votes have up to 75 bytes of space where users can vote on other things besides, say, like the validity of the last block, which I'll get to in a minute. And the way you end up getting these tickets is you lock your coins to sort of do a proof of sacrifice. So what was done here is very similar to what was done with Bitcoin. The gamification of voting into a rolling lottery, which is very similar to proof of work. You do a proof of sacrifice to demonstrate that you're not just, to demonstrate that you're at the casino and you're serious. And you do that, you obtain the tickets. And that takes a little while. And it also acts as a second authentication factor on the proof of work. Proof of work is, basically the single authentication factor that there is in Bitcoin on blocks that go into the blockchain. So if you lack this proof of stake validation on your blocks, the blocks are not considered valid. So every vote that you make, so there's this rolling lottery, you buy tickets by locking coins, and every time there's a vote and the vote gets included in a block, you get a subsidy for that vote. So basically, it's a pseudo-random process, and you get this reward irrespective of how you vote. So just that you vote is what really counts. So basically, you're being paid to come to the ballot box. We don't really care how you vote. And to an extent, this allows you to generate semi-passive returns with relatively low risk. In a lot of cases, at least currently with the current financial situation, you can't really obtain a low-risk return. You can leave your money in a bank account. Good luck getting much interest. And this is so what we're trying to do is have a return to what people would call sort of, old school banking, where you put your money in a bank, you can slowly gain interest. But what we do is that we force you to do something useful in order to gain that interest, which is voting. So by laying all of these birds on top of each other, beyond making for a fun graphic, what it does is it gives representation to users in the system. Because the main problem that I observe with pure proof of work currencies is that users don't have representation at the sort of governance level. And this basically restores that, in addition to doing these other things. So I feel like this image is particularly relevant to Bitcoin and to politics in the United States and Europe. So instead of just focusing on features or the latest privacy thing, what our observation is that the most interesting code in all of, in every cryptocurrency is really the consensus code. The consensus code is the magic that makes it all happen. And without this code, cryptocurrency is just another sort of pipe dream or a semi-functional piece of software. So we view this engine as being the thing that we want to build out, improve, refine, and ultimately make perfect. As you're aware, consensus code is unusually brittle and difficult to handle. If you screw up if you introduce forking bugs when you're writing consensus code, it can lead to all manner of problems for your project, because the chain can grind to a halt, the chain can split. This is just bad. It causes people lose money. it's just like when the bank shuts down. The bank shuts down and things are not good. People are upset. So in order to prevent these breakages, what we do is we accompany all of these changes with full block, essentially regression tests, and just generic test coverage. The reason being is that if you can demonstrate that a test chain doesn't fork under these various corner cases and edge case scenarios, you can say with a high confidence that the system is sound and that it will not just sort of break apart once you run it on mainnet. Further, we are not fans of this idea that the development group can run roughshod over the users. We see our role as steering development, but if people don't want to do something, we don't think they should have to do it. So basically, no changes unless it's an emergency hotfix will go in without the explicit approval of the proof of stake miners. And in order to do this right, we have to focus on testing. Testing is typically something that most engineers are not at all excited by, because it's not like new functionality, it's not sexy code, it's code that it's like, oh, make sure all the corner cases work. So, I experience this as somebody who works with developers. People don't typically want to write this code, but it's super important here. The brittleness is serious and it is very real. So far, we've managed to avoid any serious, hidden consensus or forking bugs. We did run into a minor one that when we released one version, we had adjusted consensus before these automated full block tests went in, and that was a bit of a mess. So we're very careful with modifying consensus code, and we actually have a standard procedure for it now. The code used to test to do the full block tests in DCRD, which is our consensus daemon, is fully independent from the consensus code itself. Now, in fact, the only other tests that I'm aware of in other cryptocurrency projects for testing consensus essentially reuse the same consensus code to test their own consensus code. Now, it's going to catch most bugs that way, but to be fully complete with it, you want a separate re-implementation of these rules as your test harness, and that has been done thanks to Dave Collins, one of our developers. Oh, and I forgot, these tests run automatically now. Every time you push a PR to the DCRD repo, it makes sure that these consensus rules aren't broken and nothing has changed. So basically, it's automated. It's an automated system for preventing reversions and regressions. Okay, on to hybrid proof of work, proof of stake. This is this section of the talk is work that was basically done prior to our launch in February of 2016, and it's important to understand how this infrastructure works in order to understand hard fork voting, which is sort of the meat of what we're working on right now and will be releasing in the not so distant future, like a month from now. So I expect everyone's familiar with RoboCop. I feel like RoboCop is a good sort of a metaphor or a mascot for this hybrid proof of work, proof of stake, in the sense that he's half man, half machine. He's conflicted. I view proof of work as sort of the machine side and proof of stake as the human side. I don't know how much further I can stretch the analogy, so I think I'll stop there. But the way the proof of stake layer works is that this is a dense slide. I'm going to warn you in advance. Proof of stake is opt-in. Nobody has to participate. You can optionally lock your coins to get these tickets, and then those tickets, after a maturity period, become eligible to be selected in a rolling lottery. In every block, there's 5 of these things selected. So there's a stake difficulty algorithm, and that basically takes the price of the tickets, and the tickets go up and down. And this is very similar to the proof of work difficulty, in that it's self-adjusting. As Charlie's aware, it's not that great an algorithm, and what it does is it's supposed to maintain a stable target ticket pool size of roughly 40,960 tickets, and it's supposed to not spike the stake difficulty too much. And what it does is it looks at the history of the pool size and the history of ticket purchases, and then uses that to sort of create new ticket prices. The subsidy of each block is split three ways. This is how we accomplish what was mentioned in one of the first couple slides, which is that 60% of the subsidy goes to proof of work, and that's because, if you're doing proof of work, you have to buy hardware, and you have to run it, you have to supply it with power. So we figured it still makes sense for the majority of the subsidy to go to proof of work miners. Then we figured 30% for proof of stake because it's roughly the right amount to be giving people on a steady basis. And the reasoning there is that if you have the proof of stake subsidy too high, it becomes trivial. If you showed up early, you own tons of coins later on. So we wanted to keep the subsidy for proof of stake high, but not too high. So we set it at 30%. And the reason we set the development subsidy to 10% is I'm of the feeling that if you can't do it with 10% taxes, you probably shouldn't be doing it. So that's where we set that watermark. And I acknowledge that when the project started, 10% of the of the coins is just nowhere near enough to build everything out. So I paid to have all that stuff built out. There's 5 votes per block. That breaks down to 6% of each block subsidy, and then there's roughly 1.6 to 1.7 DCR reward per voted ticket. So I had mentioned that proof of stake overrides proof of work. If enough of the proof of stake miners on block N vote no on their first vote bit, and this is a fixed vote bit, I'll get into this in more detail later. If over 50% of the votes included in the nth block vote no on the previous block, then the proof of work reward is stripped from block N-1. So let me give you an example. Somebody might mine an empty block, or someone might mine a block with a nonsensical block version. Basically, there's a number of sort of bad behavior things that could occur with proof of work miners. If the proof of stake miners are sufficiently upset about it and organized, they can basically invalidate the rewards from that previous block, which acts as a financial mechanism to penalize bad behavior. So the first vote bit so when I talk about vote bits, there's up to 75 bytes of these things in every vote. In practice, we only have one bit set currently, and what that does is that bit votes on the validity of the prior block's proof of work. So that one is going to stay because it's basically an easy way to have a check on the power of proof of work miners if they start to misbehave. Proof of work miners have to include votes in blocks that they mine, or else they lose subsidy linearly with the number of votes they don't include, and they must include at least 3 votes. So this means that if a proof of work miner wants to try to fight with or cause problems with proof of stake, they could try to, in theory, not mine the votes that are supposed to go into each block. If those votes are not mined, if you only mine 3, or if you only include 3 out of 5 votes, you're only going to get 60% of the block subsidy. So that's a stick to basically make sure that proof of work miners do what they're supposed to. Dun dun dun. Okay. So in order to understand I think that to some extent you understand the motivation of behind what we're doing here, but I'll just lay it out a little bit more explicitly. So there are serious problems with pure proof of work. So proof of work miners dictate if, when, and which consensus changes occur. I mean, a perfect example of this is BIP 141, which is sort of just idling right now and may or may not activate depending on what people do or don't want to do with respect to the mining. So that's an actual example. So when we started Decred back in early 2016, in the run up to it, I had written a blog and I was like, well, this could happen. It could be that proof of work miners obstruct certain changes to consensus. And at the time it hadn't happened, but sure enough, it's basically happening right now. So it's kind of timely for the talk. Proof of work miners can do denial of service attacks and censor transactions. Now, this is only somewhat effective currently, right? Because if there's one proof of work miner who will include your transaction, your transaction will get a mined eventually, but it could take a long time. And there's no way currently to entirely blockade a particular transaction, but that's how it is right now. And denial of service attacks, we've seen some of those in the sense that people do mine empty blocks. I think they still do it episodically, but it's not very common, and it's a game so that their block propagates quicker and they get the subsidy they need. So this hybrid system gives proof of stake miners the ability to kick the proof of work miners in the shin when they're misbehaving, and I think that that's a good thing because it puts the people who hold the coins back in charge. Now, the people who hold the coins may well be the proof of work miners themselves, but they have to not go to the casino and not sell all their coins. So to return to the, in terms of motivation, this passive, semi-passive, lower risk return that you get by staking coins is, it's intended to be similar to old school banking so that it motivates people to keep playing this game. It's our gamification bait. And more generally, what we're really trying to do is we're trying to have a currency that adapts to the will of its users, as opposed to, it being a game where a small, cabal of people are in charge the whole time. By having this hybrid proof of work, proof of stake system, we use proof of work, which we know works and works well, and then we bolt on a proof of stake layer on top of it to fix the governance problem. It's sort of the least we can do to fix the situation. There are some additional details that I think are, bear covering. So the way the 5 tickets are selected from the ticket pool to vote every block is pseudo-random. I want to say it's a hash of the previous block that is used to select the tickets that that have to cast votes in the next block. Now, this is the caveat that's definitely worth mentioning. If you want a proof of stake mine effectively, you need to either have a voting wallet or you need to use a stake pool. Now, the point here is that when the votes are called, they need to be submitted in a matter of seconds. That is, the latency between when the mining or the proof of work mining on a block starts and when the previous block showed up needs to be on the order of maybe 3 to 5 seconds. So that in that time, you need a proof of stake mining rig connected to go, I'm voting this ticket before the proof of work miner starts and leaves that ticket out. So there's a couple ways to handle this. One is to have your own machine connected 24/7, 365. I do that because I'm a security nut. And then you can also use a stake pool, which is basically a proxy where they don't control any of your coins, but they cast the votes on your behalf, so that you don't need to have a machine running 24/7, 365 at home and monitor it for uptime and all that stuff. So in terms of purchasing tickets, there's 2 options. You can purchase them manually, which makes sense if you're a smaller ticket buyer. Like if you don't have a whole lot of Decred and you want to buy some tickets, you can sort of watch the ticket price, wait for the time you want to buy, and click and buy. Whereas if you have a large number of tickets, because Company Zero has a lot of tickets, these tickets have to be replenished on a regular and ongoing basis. And the same thing goes for anyone who is a major stakeholder in Decred. So there is a system called, or sort of a subsystem inside Wallet called Ticket Buyer, and that goes ahead and purchases tickets according to a series of rules. So I figured that sovereignty is something that people don't typically explicitly talk about with cryptocurrencies. So I figure it bears some repeating. This is Ed 209. That's proof of work versus hybrid proof of work, proof of stake. Doesn't look like it's going so well for proof of work, proof of stake. So Bitcoin, it's elegant and simple. It has, its consensus code is relatively minimally complex. But there's problems that come out of this simplicity. By creating such a simple solution, it overlooked the governance of the project and sort of punted on it. The definition of sovereignty is that you are free from the external influence of third parties. And, Bitcoin users are most certainly not free of the influence of the proof of work miners. So because of this sort of demotion in terms of like share classes that you receive as a Bitcoin, holder as opposed to a miner, rectifying the situation for a pure proof of work currency like Bitcoin would require a hard forking change, which I would expect to have almost no chance of passing. But that's me. I'm sort of pessimistic on that front after working on stuff for a few years. And so what we did is, the calculation we made was the complexity added by the hybrid proof of work, proof of stake is small enough that it's worth implementing, because the value you obtain by putting the sovereignty back in the hands of the users who can, optionally participate in mining, the value there is huge, because in the long run, the currency will do what its owners want as opposed to the bookkeepers. Now, the only barrier for mining, proof of stake is a certain amount of technical skills. You just have to pay attention. You have to know the rules, and then you also have to have a certain threshold amount of Decred to purchase tickets. Now, this in the long run could become a problem if Decred ends up being worth a lot of money. But there are other solutions that can be undertaken if and when that situation comes up. So the voting component of this, bears a quick review, because I'm about to get into the hard fork voting part. The voting infrastructure, as I said before, it can be used to signal. That is, that we could ask users, what color do you want us to change the logo to? Do you want to shave my cat? And this was a joke from a previous talk I gave. Do you want to add Lightning Network support? Do you not? Do you want to remove the ability to censure the previous proof of work block? There's all kinds of issues that can be chosen to vote on, and there's an enormous amount of space for it. So 75 bytes. I mean, we could vote on. That's 600 bits. So, you could vote on easily 100 different things at a time. Not that I think that that's such a great idea. I just figure it's possible. We're going to keep the number of issues small initially, because if you start changing, consensus code is delicate, and if you start changing things too much, things are going to go bad. Something's going to break. So we're going to be kind of gingerly with it at first. We're going to take our time and not really press it and try to, break the system. And in terms of hard fork consensus changes, these are the things that I think are really the most interesting, because, the consensus code is really where the magic's at. So most changes that are interesting are going to be hard fork consensus changes. You can bend some of these things into a soft fork sort of, SegWit style, but our intention was to basically make infrastructure that didn't care about that, because trying to, make everything into a soft fork isn't necessarily the greatest way to keep things simple. So voting on a new set of issues begins once a new stake version has been activated. And I'm going to have to get into this in detail, because currently say with Bitcoin, there's the block version, and the block version is really sort of the one metric that everything runs by. If the block version is X, then there's certain soft forks that are activated. If the block version is X plus 1, then other soft forks are activated, and so on. But in the case of Decred, we have both a block version and a stake version, and then there's also a third one, which is a vote version, and I'll be getting into that shortly. But the way this works is that there's a staged upgrade that occurs, and then during certain intervals called RCIs, rule change intervals, we tally votes for the various issues, and if they hit threshold, then they activate after a lock-in period. And I'll get into more detail about that in the next section. So, hard fork voting summary. The real reason that we made Decred was so that we can fix this governance problem. And it's, voting on hard fork consensus changes is really the most interesting thing we can do, so we've raced towards that over the past year. Doing this right requires a careful upgrade path, and we thought about doing it several different ways, but the way we ended up choosing was what we felt was the simplest and the safest. So there are other systems like my understanding, and I say this just because I haven't read the source code and I haven't assigned developers to read the source code. There's other systems like Dash that have distributed governance where the voting system they have is used to signal changes. For example, people will vote and then signal that, yes, I would support a hard fork with these properties. However, that isn't tied into the consensus. The hard fork still is a centrally administrated activity. Whereas in our case, what we do is we bake in the changes into the consensus daemon and possibly the wallet, depending on the changes. We bake these changes in ahead of time with conditional statements that say, if this voting threshold is passed, activate this new section or change this section of consensus code. So when we do this hard fork voting, this is not a signal. This is not people trusting us to do things. It's we've already demonstrated that we trust the users to do what they want, and we push the code to them, and then it self-activates. And per my previous comments, if there's a potentially like a large chunk of development work that needs to be done, and we and we're not sure if the users really want to support it, what we'll do is we'll ask, do you support this before we start the work? And this process will obviously become more refined over time. So the other thing is that, this is a question that may come up in a little bit here, is that hard fork consensus changes are risky for Bitcoin, but that's because Bitcoin is a pure proof of work currency. And in our case, the fact that we have a lower risk way to move, and it's a consequence of how proof of work, proof of stake works, we can have episodic hard forks with a very low risk of long-lived minority forks. Something similar to the ETH Classic debacle, where it's people really wanted to not make some rule changes and then were able to stick it out long enough to keep the currency going. We make that a lot harder so that the probability of that happening is going to be much, much lower. So the motivation, hopefully I'm not beating a dead horse. Hard fork voting is extremely dangerous for Bitcoin, and I feel like or hard forking for Bitcoin is a dangerous proposition, because it begs the question, once it starts, when will it stop? If there's one that happens, it's like, oh, we want a 25% bigger block size, then what's to stop somebody from next week going, I want another 25%, and so on and so on. So, I mean, my sense of the hard fork situation with Bitcoin is that no one wants to do it because the emperor has no clothes. And once you start doing it, it becomes very clear that the emperor has no clothes. Additionally, because the Bitcoin core repository has become so politicized over the years, it's difficult to decouple legitimately bad ideas, like, say, bumping the block size to 2 megabytes, from ideas that they just don't like. it's to the point where there's, I feel like it's almost focus group before anyone says anything, and there's talking points. It's just, it's frustrating. So I want to stay away from that. So in the long run, making Decred great again may involve changing the consensus code. We may not have gotten it right on the first pass, and I acknowledge that. And I mean, I feel like to say that any piece of software is perfect as it's written, I imagine it's possible, but it's very, very, very improbable. So we've built this hard fork voting system with correcting, improving, and enhancing things as we go in mind. So the stabilization problem or the stabilization that we have from hybrid proof of work, proof of stake in the context of minority forks is the following. We chose a threshold for consensus changes to be 75%. Now, the reason we chose that is because that creates an orphan rate of roughly 90%. By having an orphan rate of 90% on newly mined blocks, that basically multiplies the cost over any sort of proof of work, costs by a factor of 10. If you're going to try to, like, let's say the 25% who voted no on an issue wanted to leave and walk out. In order to do that, they need to perpetuate their chain and keep the ball rolling. But in order to do that, they need to basically spend 10 times as much as usual on top of any additional cost increases that would come from proof of work. So if half the proof of work miners go with, the number changes and so on. So basically, this hybrid system is unusually stable under minority forks, which is a good thing because I think most people do not want an F-classic situation. So there's some details here, and the details are related to how the staged upgrade process works. So you need to basically verify that several of the parties are working in concert. You need to make sure the proof of work miners are upgraded. You need to make sure that the proof of stake miners are upgraded. And then you need to actually kick off the voting, and then you start enforcement. So the way it runs is that proof of work miners signal they have upgraded by incrementing their block version. And this says to the network, these proof of work miners are running the latest consensus daemon that has these hard fork voting issues encoded into them. So basically, it's got the changes wired in. Then proof of stake miners signal they've upgraded by using the latest vote version. So that, what that signals is that there are these vote bits in these issues that the wallets understand. So if the wallets understand these pieces, then they can make sane votes. And then the tallying of the votes begins after the stake version bumps. So what happens is that proof of work upgrades, the block version goes up. Proof of stake upgrades, vote versions go up, hit a threshold, then the stake version bumps. Now, once the stake version bumps, it means that we're ready to start tallying votes. Then there's a period, and now I'm not going to get too far into this. You guys can ask me questions about it if you want. The start of the vote tallying interval after the stake version bump can take 0, 1, 2, or 3 weeks, and it's basically an alignment problem with these intervals. One of them is 4x the other. There's not a very good way to avoid that. If an issue gets voted in, it gets locked in, and then a full RCI, a full rule change interval passes, and then the locked-in issue activates and changes the consensus rules. So basically, the last part is a delay. And I mean, this whole process is actually very similar to the BIP9 process that's used by Bitcoin Core for doing soft fork upgrades. So basically, we took that process and built it out so that it handled the proof of stake layer and allows for more substantive changes than soft forks. Failure modes, everybody loves them. So, you can go in and go, oh, this is fine. This is absolutely fine when the house is on fire, and everyone's familiar with that gun show comic. And it's always important to think about the worst case scenarios. What can happen if things break very horribly? Consensus code is delicate. If you screw it up, things are going to go bad. The good part is there's only two types of bugs that are really present. There's a chain seizing bug, and we actually experienced one of these when we rolled out 060. Someone had incidentally changed some consensus code before we had the automated full block tests integrated, and that caused the chain to seize for people who had just upgraded to 060. We made a patch release. The other fix is for people to downgrade. So these bugs are bad, but the worst kind is the chain splitting bug, which I think Bitcoin experienced, I want to say back in 2013. I didn't look up the details of that one. And we haven't encountered one of these to date, but it's much harder for this to happen with Decred because of the hybridized proof of work, proof of stake. If it splits, the proof of stake has to split somehow. So that's going to basically push one chain forward relative to another, and the problem won't be as severe as it would be in a pure proof of work currency. And so since we only implement things that people approve, if we ever did encounter one of these bugs and we had to make a hot fix, we're just going to make a minimal fix so that everything works and sort of step back. And then if any more substantive changes need to be made, we will have people vote on them. So Decred historically, we've solved a few problems. We've got a few things that we solved. We've solved opt-in on-chain representation that overrides proof of work. And their monopoly on sovereignty. We've got a system for continuous improvement and extension of consensus code, and an ongoing funding source for improvement of the infrastructure. Now in the future, we had 13 months to grind this stuff out, and we've got a lot more stuff to do. Got to add Lightning Network support. That is not a small amount of work because syncing the changes from BTC Suite is a ton of work. We've got to create a proposal system so that people can, right now we don't have a system where people can go, I really want to change this. And, we have a forum, but that's informal. We want to create a system where people can do that and it's transparent and public. Decentralized control of the development organization funds, that's planned. I'm not exactly sure how to do that one yet, but we'll figure it out. We're going to enhance user privacy. I'm not going to say too much about this because privacy is such a hot, like a hot topic that people compete on, so I'm just kind of avoiding it. I want to ambush people with it. And then there's a little secret side project we've got going called Charybdis, which will integrate with Decred, and we'll see what happens with that. That's a bit of a dice roll. It may surprise everybody. And now it's time for questions. Talking to the box.
Thanks for the great presentation today. I'm kind of curious about how the system maintains stability in the case of a bitter disagreement in the community. There's some major issue about the future of the protocol. There's an intractable kind of debate that's happening. What keeps the rules from switching back and forth in all these voting rounds where there's no ability to have predictability? So like there's SegWit for a few months, then there isn't SegWit for a few months, and then people don't know how to build on top of it.
I think that's a good question, and the system is built such that changes can go both ways. That is, you can add functionality, and then let's say later everyone's like, "Whoa, this is really broken. I think we got to remove this." It can. Now, I'd expect that if a feature was, at least relatively successful and went over well, by making a 75% watermark for making these changes, it's the tyranny of a strong majority is basically what we're sort of left with. And, contentious issues, you're totally right. It could activate consensus rule A, deactivate consensus rule A. These things could happen. But my sense of it is that the process is slow enough, like, for example, between hard fork voting intervals, probably a minimum of 2 or 3 months, there's some time for people to sort of like breathe and look and, make a decision. So I think that these yo-yoings are possible, but I'm not too concerned about them.
Well, with the 75%, that's 75% of the votes that are cast, but that's not necessarily 75% of the community. right?
That's another fair observation, which is that, the issue with all kinds of voting, whether it's proof of work or proof of stake, because they're both voting in a way, is that there's always these, how do you determine who is running a Sybil attack on you over the internet? Mm-hmm. And so because this stuff's all online, it's like you need something finite or something bounded by reality, like proof of work, or bounded by a certain number of coins to control how these decisions are made.
Should I attempt this? Why is hybrid proof of work, proof of stake better than proof of stake?
The issue, it's a good question, I didn't include that in the talk, is I feel like that's addressed pretty well by Charlie's proof of activity paper, in that proof of stake is good as a standalone, but it has the problem that when it's pure proof of stake, there's the but nothing is at stake situation where if I show up early and I put 10% in, I'm always going to be just making a ream off of that. And I feel like proof of stake has the advantage that it doesn't have all this sort of like physical reality, expensive mining hardware, lots of power consumption and stuff. So there's obvious benefits to it, but it's very much like a, sort of like an investment scheme in the sense that it's like, if you weren't at ground level, it's like you're at a big disadvantage to the people who have been there the whole time. That's why we didn't go with proof of stake. And I feel like the other thing about proof of work is that it has flaws, but it most definitely works. So I figured throwing out something that works isn't necessarily a great design decision.
And the second question is, for the blocks, you need the proof of work proof on the block, and you need the proof of stake votes on the block. How is the block itself determined? Like, I would have to imagine that, like in Bitcoin, the block is determined by the miner, and no one sees the block before the miner broadcasts it with the proof of work proof. But in the hybrid system, you need multiple authorities to coordinate on proofs on the same piece of data that.
Okay, so mechanically how that works is block N is created. It is broadcast and relayed. Excuse me. It's broadcast and relayed, and what ends up happening is that the votes on block N+1 are determined by block N, right? So everyone who's voting has a consensus daemon. That thing, the consensus daemon says, aha, one of your tickets needs to vote. That person fires out the votes. Those votes get relayed across the network. And then the proof of work miner who's waiting, there's proof of work miners wait like 3 to 5 seconds before they start mining the next block because they have to include those votes. So that's mechanically how it works.
Sorry, but so they have 3 to 5 seconds to submit their votes to the network, but what are they voting on? Like, where's the proposal for the block itself coming from?
What do you mean the proposal?
So the proof of stake voters have to vote on the next block in the chain, and the proof of work miner has to create a proof of work for a specific block. Mm-hmm. Like, where is the original unauthenticated block, just the raw, the group collection of transactions coming from? Like, what are the proof of stake miners voting on at the point where they're
so for example, when you're voting on block N, the votes that are included in block N are really votes on block N-1. So that if block N-1 is, let's say it's empty and it doesn't have any regular transactions in it, and there's, everyone has a policy who's a proof of stake miner that says, I am voting no if people mine empty blocks, then they'll vote no, and then the previous block's proof of work reward gets stripped. So it's sort of you're voting on, the votes that get included in block N are really voting on block N-1.
Got it. Thanks.
So we're on time now, but Jason's around for lunch, so if you want to ask more questions, feel free to talk to him about that. Thank you.